Dear brothers and sisters, classmates of ITS, today we are talking video file formats. As video is dominating the internet, today there exists a number of different methods for storing and transmitting media files. One method is to include the files in what's known as a file container. Most file formats are actually container formats. Earlier today we convened an emergency council to discuss the matter of analyzing a file format. After much heavy-hearted discussion the decision was upheld. We would reveal the anatomy of MPEG-4, illuminating its contents. MPEG-4 Part 10 is a standard for video compression. It is the MAC of format containers. It is also known as MPEG-4 Advanced Video Coding, or H.264. You will find H.264 in almost every modern applications, from phones to camcorders, even on Blu-ray discs. Video is now encoded in H.264. Its quality versus file size ratio is the shizzle. The main disadvantage is that it is very slow to encode as it has some vast algorithmic improvements over other formats. In the interest of variety I will list some other well-known file formats, as you will find videos mostly wrapped in the following containers. 1. Motion JPEG. This is an older format used by some digital cameras. 2. DV and HDV. DV is a tape-based standard and is common on camcorders that use many DV tape cartridges. HDV was created to allow capture of high-definition video to many DV tape cartridges, while DV itself is limited to standard definition. 3. AVI. This is the most basic container. It's just there to interleave audio and video. It was written in 1992 and is still used today. It has quite a few disadvantages. No aspect ratio information. No good support for codecs that use predictive coding. Go Windows. We shouldn't use AVI. It's probably best to avoid using this or Windows in general. Containers. Why do file formats need containers? There are several reasons why. Maybe you want some audio along with the video. Maybe you want to skip to a certain part in the video. Both audio and video should be perfectly synchronized. The video might need to be transmitted over a network and split into packets. For all of those reasons there are containers. What they do is wrap a container that becomes synchronized with video and audio frames according to their presentation timestamp, which makes sure they are displayed at exactly the same time. Now, let's get down to business with the codecs. Raw video and audio data would consume vast amounts of storage space. For example, uncompressed, high-definition video recorded at 60 frames per second eats up 410 gigabytes per hour of video. This is where codecs join the party. A codec is merely a method for encoding or decoding data. The term codec is one part compress and one part decompress. They have only one job. They take digital data and either compress them for transport and storage or decompress them for viewing or transcoding. Once the media data is compressed into formats and are of a reasonable size, it needs to be packaged, transported, and presented. That's the purpose of container formats. Codecs still sound confusing. The short version is, thousands of codecs exist. Many codecs are designed to emphasize certain aspects. For example, a digital video using a DV codec for a sports event needs to encode motion better than exact colors, while a video of an art exhibit needs to perform better encoding of color and surface texture than motion. With that in mind, there is no right or wrong codec. There is no one best codec. It only boils down to what your intended use is.